Hi, welcome to 4.1, the electromagnetic spectrum. You've been given a handout that is fill in the blank that's going to go right with this video. So let's get started. This is your introduction to light. Light can carry heat and warmth. Light has color. Light can be bright or dim. Light travels almost unimaginably fast and far. And light travels in straight lines, but it can be bent by lenses or reflected by mirrors. So what makes light? Notice in the diagram that the electron moves down an energy level or up energy level. This is where it requires energy or it gives off energy. Atoms make light when the electron drops an energy level. Atoms make light when the electron drops an energy level. So let's look at electromagnetic waves. Light, like sound and heat, is a form of energy. The entire range of light is known as the electromagnetic spectrum. All light can travel in a vacuum, meaning it does not need a medium to travel through. That's how we get it from the sun. So this is just a diagram of the electromagnetic spectrum. You will be given a handout of this after 4.1. So the entire range of electromagnetic waves, including all possible frequencies, is called the electromagnetic spectrum. Don't worry about writing these down. We will go over each one individually, but they include radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays, and gamma rays. This is a diagram, and again, you'll be given a copy of this that just gives you some examples and describes the energy, frequency, and wavelength. Again, another diagram in much more detail about how big each one of these things is and how far it can go. So let's look individually at each phase or each wavelength in the electromagnetic spectrum. Radio waves have the longest wavelength in the electromagnetic waves. Uses for radio waves are television broadcasting, AM and FM broadcast radio, avalanche beacons, and heart rate monitors. Microwaves are the next step. They have a wavelength between 1 millimeter and 1 meter, and they're used in microwave ovens, Bluetooth headsets, cell phone communication, broadband wireless internet, radar, GPS, and video game controllers. If you have an Xbox or a PS4 and you are able to continue to play from the other side of a wall, it's because it does not have a line of sight that it needs. It uses microwaves. The next one is infrared radiation. These are wavelengths in between microwaves and visible light. The uses are night vision goggles and regular remote controls. They literally beam an infrared beam of light from the remote control to the television or to the DVD player, Blu-ray, or whatever, and it has to have a line of sight. This is why my remote doesn't work when my dog is standing in the way. This is also what they use for heat-seeking missiles. When they say we're going to paint the target, they don't actually go out with a can of paint. They shine an infrared beam on it that cannot be seen by the naked eye, and this is what the heat-seeking missile will find. Thermal imaging is also another use of infrared radiation. Visible light. This is the only type of the EM wave that you're able to detect by the human eye. This makes all the colors of the rainbow, Roy G. Biv, everything that you see. The next is ultraviolet light. These are shorter wavelengths than visible light. The uses are black lights, sterilization of medical equipment. If you've ever been to the dentist and all those wonderful medical tools they put in your mouth, those have never been washed. They actually sterilize them in an autoclave that shoots them with ultraviolet radiation, and that's what sterilizes them. It kills 100% of bacteria. This is also what they do to disinfect water in foreign countries. They pass it through a tube that has ultraviolet lights, and it will sterilize the water so they can drink it. This is also security images on money. This is sometimes why you'll see banks or in movies them running a black light across the money, because there are security images on the money that can only be seen in ultraviolet light. This is also the bad one. This causes sunburns. Next one is X-rays. These have a tiny wavelength and high energy waves. Uses obviously are medical imaging, airport security, and inspecting industrial welds. If you ever become a welder and they have to, you're welding a ship together or a pipe together, in order to see if it has any cracks in it, they will actually X-ray it. And if they can see anything through the weld, it has to be taken apart and redone. The last one are gamma rays. These are the smallest wavelength, highest energy EM waves. The uses are food irradiation, cancer treatment, and the treatment of wood floor. When you shoot any food or anything with gamma radiation or gamma rays, it will kill all the bacteria and everything in it. This is how we keep our wood flooring from growing. All right, well, that is 4.1 on the electromagnetic spectrum, and here's the song that goes with it. Thanks for watching.